Two and a Half Admins, episode 206. I'm Joe.
I'm Jim.
And I'm Alan.
And here we are again. Everybody is waiting for us to talk about the CrowdStrike outage.
Well, it wasn't so much a CrowdStrike outage as a distributed outage caused by CrowdStrike.
Yeah. A CrowdStrike caused outage.
Yeah.
So this was a pretty ugly one, and I know I got pretty lucky with this one. I believe Alan did too, but essentially anybody who was using CrowdStrike on their Windows computers got treated to a day or two of endless blue screen loops. And the reason for that is because the CrowdStrike application itself was blue screening the entire machine because it runs at kernel level. So if it tries to, for example, access an area of memory that it should not have the ability to access, Windows blue screens, because it's technically speaking the kernel that's trying to access memory that it shouldn't be allowed to access, and therefore all memory access is now considered unsafe, and that's why the machine immediately blue screens.
Yeah, Windows is actually doing its job there, right?
Yes, and in a typical configuration, Windows not only blue screens, it immediately reboots, which of course gives it the chance just to immediately blue screen and reboot again and again and again and again. Now, the interesting thing here, this was caused by an update that CrowdStrike pushed, but it wasn't actually a code update, technically. The update that was causing these crashes was actually in the form of a data file. Something was mangled in this data file, and this very low-level kernel driver that CrowdStrike uses that parses, these, they call them channels, these pieces of data that it, routinely pushes, which basically allows CrowdStrike to identify heuristic patterns that it thinks are bad news and it should shut down, is what this boils down to. But at any rate, they're not really trapping for errors apparently within those data channels. They're just expecting them to be properly formatted and correct. And this time, that obviously wasn't the case because something in the corrupt data channel caused the CrowdStrike kernel driver to access RAM that it had no business accessing, and that would in turn blue screen the machine, and it would just keep blue screening over and over and over until somebody could get to it and interrupt the boot loop by booting into a, safe mode with no drivers loaded. You would need to know that CrowdStrike was the problem to begin with, which until the news really propagated wouldn't have been all that obvious. It's not very easy figuring out what caused a Windows blue screen these days. It was never super easy. It's gotten much more difficult than it was, say, 15 years ago. But at any rate, the mitigation for the moment would have been to interrupt the boot loop and remove the CrowdStrike driver, at which point you could go on about your day. But this is something that would require direct intervention from somebody who, was either a professional IT person or had a lot of IT skill and know-how, and they have to do it right there. You can't just push an Active Directory group policy to fix it because the machine won't boot and stay booted for long enough to get to it.
Yeah, so basically CrowdStrike is installed as this boot time driver. So it happens very, very early in the startup of Windows so that it can defeat malware that tries to start very early in the startup of Windows. And it's not equivalent, but the rough equivalent of, the virus scanner definition update files that we all used to be familiar with that CrowdStrike put out, which in this case was to look for and prevent attacks against a feature in Windows called named pipes that some new malware was using and abusing. And so they put out this definition update that the CrowdStrike kernel engine would be able to see and know, hey, if we see this pattern, that's bad, stop it, and keep this machine from being compromised, right? The whole point of CrowdStrike is it's cybersecurity software that's supposed to keep these endpoint machines, the regular Windows desktop machines and servers, from getting compromised by malware. And in this case, because it's such an early boot time kernel driver, when there was a problem with this definition file, it would cause it to panic over and over again. And it turns out that, the panic was caused by the code trying to dereference a pointer to 0009F, which basically suggests it was actually dereferencing a null pointer at an offset of 9F.
Although CrowdStrike swears up and down that the root cause was not a null byte in the channel file.
Well, no, it wasn't a null byte in the channel file. It was whatever the channel file did made the software try to read a pointer at a certain offset, but the pointer was 0 instead of some address in memory. And so it was trying to read the very first bytes of memory, and that's never valid.
I think we may need to clear up some confusion here, because we've talked about null bytes and we've talked about null pointers. And CrowdStrike swears up and down that the root cause was not null bytes, but now we're talking about null pointers. So maybe we should explain the difference.
Yeah, so a null byte is basically in a file. Every byte has basically a hex code that is the value between 0 and 255 that represents what byte this is. And most of those correspond to like letters and numbers on your keyboard and so on. But if it's actually 0, that's a kind of special meaning. Like in most C programs, that null byte is what you put the end of a string to say, all right, this is the end of that string. It's not something you normally have in a lot of files. But in binary files, it can happen. And some people seem to have misunderstood that it was just having a null byte in this definition file caused CrowdStrike to crash. And it wasn't something that simple. In the completely unrelated concept of a null pointer, so normally a pointer is basically an address in memory. A certain place in memory in your computer, there's going to be this data structure, and then we're going to seek into the offset 9C of that, and it's going to contain this specific bit of data that the program is looking for. But you can have a wild pointer where that pointer just is some random number and points off into who knows where in memory that contains who knows what. And if you misinterpret that as the data you're trying to process or the function you're trying to run, that could be bad. But in this case, the pointer was actually to just the number 0, which is not a valid memory address. And then the offset of that 9C just tried to read a couple of bytes into that null pointer. And when the operating system sees that, it knows, okay, the pointer you're trying to access wasn't initialized yet, right? It's still set to 0. It was supposed to be set to some location in memory where you had loaded that data, but it wasn't there yet. And so the operating system does the only thing it can do, which is, well, I'm not going to let you just go and run off and break everything. So we're going to stop the computer and blue screen and say, you tried to read memory that isn't set. And that's why it crashed here.
The reason this doesn't happen when the applications that you use every day try to access memory that they have no business accessing is because they're not running as kernel code. They are a separate application, so the kernel, which controls userland applications, can say, nah, I don't like you, and kill just that application. But because this CrowdStrike driver is technically part of the kernel itself, the kernel itself is saying, I tried to access memory I'm not supposed to have access to, and the kernel can't kill the kernel other than by just shutting the entire machine down, which is exactly what happens when we talk about a blue screen. A blue screen either halts or restarts the machine.
Yeah. And so because of the fact that any code you run in the kernel, if it gets anything even remotely wrong, can take out the whole system, Microsoft came up with this concept of signed drivers, where drivers like this have to be vetted by Microsoft before they can load into the kernel, where they might be able to, A, if malware is able to load itself in the kernel, it can do anything CrowdStrike can do and hide itself from CrowdStrike, and that'd be bad. And B, just it ensured that drivers actually get tested and meet a certain level of quality before they happen. Of course, they only can test it so much. And in this case, because of the latency of getting that driver signed, CrowdStrike doesn't update that driver multiple times a day to keep up with the newest malware. It updates these channel files that are read by that driver. And in this case, the driver just didn't have enough defensive programming to realize, hey, that's a null pointer. Rather than dereference it, I'm going to skip over this entry or whatever and try to keep going without taking out the whole computer. But it didn't have a check for that, and so it fell over.
And let's be clear here before we're done beating CrowdStrike over the head. Also, pretty clearly, this tells us that CrowdStrike does not have a working CI/CD program. Now, notice I did say working. I'm not saying they don't have continuous integration, continuous deployment at all, but this was a clear failure of that process because somebody updated this channel file and tra-la-la-la-la pushed it on out to the world, and it immediately blue screened every single Windows computer it touched. So clearly, if we had been doing a standard automated CI/CD pipeline with everything working and all the relevant bits actually tested, well, the CI/CD pipeline would have tested the new channel file, would have immediately blue screened the test machine and gone, nah, fam, that one's bad. Try again.
Yeah. In particular, it's not like in this case that it only crashed on Windows computers that also had this other thing that had a weird interaction. This was just all like 8.5 million machines that got this update just immediately died.
And instantly. It's not like it takes, 6 hours and then some counter, increments enough that it causes the problem or, whatever. I mean, we're talking about pretty much instantly. You try to boot your machine, it dies. So again, this is something that absolutely should have been caught easily by a properly functioning and complete CI/CD pipeline. Like, it's the whole point of having CI/CD.
And what about incremental rollouts of updates? I mean, this is malware that we're talking about, so you kind of want to get it out to as many people as possible, as quickly as possible. But why don't they do something like Google does with Android updates where, I'm refreshing it and it's, my friend's got the update, but I haven't because they're rolling it out slowly?
Well, you just gave the answer yourself. The answer is because they want everybody to have the updates as quickly as possible, and that's not unreasonable. Because we're not talking about just, generic operating system upgrades, some of which are security related, some of which are features, whatever. We're talking about anti-malware and just anti-mal operators, I suppose. And this is targeted, again, not at just anybody who happens to have an Android phone, but at very high-profile enterprise users who would not be happy to learn that, it turns out I'm on like the last tier and, it takes 3 extra days for me to get the security updates that might have gotten the bad guys to not own me. They want those updates quick. So there really should only be 2 tiers here. The problem is that we only had 1. The first tier should have been, the test hosts in that CI/CD pipeline. And then the second tier is production. Unfortunately, as it turns out, it seems that we only had 1 effective tier, which was YOLO production.
But you say 3 days. What about 3 hours, maybe? Wouldn't that have at least helped?
No, because it would have taken more than 3 hours for the news to get out that CrowdStrike customers were starting a boot loop. There is no way the majority of their customers would have gotten that information within 3 hours of the issue starting to happen.
Yeah, like some of this took literally people figuring out that the machines with CrowdStrike are crashing and the ones without it aren't. And eventually people being able to read the crash dumps and figure out which piece of software was causing the problem. And then eventually, we got the instructions of if you boot in safe mode and delete these specific files, then the system will come back up and work. But of course, that only happened once CrowdStrike knew to pull that update so it wouldn't just download that update again.
And let's be clear here, this CI/CD pipeline, it really shouldn't just be 1 host. At a bare minimum, it ought to be 1 host running every currently supported version of Windows because they don't all run the same kernel version. And this is a kernel driver, and you don't know what's going to break one place and not break the other. And there are a lot of folks who might be inclined to give them a pass because that sounds like a pain in the butt having to have like a separate test host for every yada, yada, yada. But CrowdStrike is making enough money. They can afford to have a properly set up CI/CD pipeline that covers all of the supported use cases.
Yeah, like if this software is installed on 8.5 million machines, then that's a pretty good number. And while it's just an estimate, the supply chain company Interos estimates that CrowdStrike has 670,000 customers. Because CrowdStrike, it's not just the anti-malware you'd normally run on like your mom's computer or something. This is supposed to be really advanced stuff running on enterprises to actually prevent state-level actors from taking over machines. It's supposed to detect that kind of stuff and stop it, right? It's not just scanning files for known viruses. It is looking for just odd patterns and weird heuristics and so on. And so I guess to Joe's earlier point about, why can't they wait just a couple of hours? Like, in general, that maybe sounds fine until you're the big tech company who got hacked because CrowdStrike had the thing to detect this, but they waited 6 hours before shipping it. And then you got hacked because you weren't at the beginning of that channel. Some companies are like, we'll pay extra to get the updates right away and not wait. But from CrowdStrike's side, those are likely the customers that you want to be more sure you're not crashing all their machines. But I will say the machine can't get hacked if it's boot looping.
I will say to your point about this not being your mom's anti-malware, this is, supposed to be extremely advanced defense software, yada, yada, yada. Well, I could make an argument that the most advanced form of theater is Japanese kabuki.
Yeah, I would say the one other interesting thing we saw out of this is that it seems like Microsoft runs CrowdStrike on a good chunk of the stuff that hosts their cloud. Right? There's a reason why Office 365 was down during this.
The interesting question here really becomes, even and maybe even especially in the case of really large actors like Microsoft, you have to do a lot of good before you wipe out the evil of causing half a day of downtime. And you have to wonder how many times is CrowdStrike saving somebody's bacon more than it's causing problems. This is not just an issue I have with CrowdStrike specifically. I'm actually kind of notorious in some circles of folks who know me as the guy who immediately uninstalls all the third-party AV and just makes sure Defender is running. Because in practice, when you actually look at the the detection rates, the positives, the false positives, the undetected, whatever, Windows Defender is usually pretty close to the top of the pack. It's not always on top, but it's always close. And it's always a heck of a lot less drain on system resources, and it causes less problems in practice, in my experience, than pretty much any paid-for third-party antivirus I've ever seen. So where the client permits it, if I find, a Norton, a McAfee, whatever, I yank it and just go back to Pure Defender.
I think the other thing here is the industry really needs to get away from monocultures. The fact that almost every airline in the US was taken out because of one piece of software, maybe United should run half of its computers running some other cybersecurity software. So if there is a problem, it only takes out half of their computers. And maybe they shouldn't use the same software as the other airline. But at the same time, you can say, if you're running the one that doesn't catch the attack and you get hacked and the other guy doesn't, then that's hard to justify that decision. But it does seem like we have this proliferation of single points of failure.
I'm just going to go ahead and make the sometimes wildly popular and sometimes wildly unpopular observation. Maybe they shouldn't all have been running Windows as the operating system on the back end in the first place. That's not even explicitly a dig against Windows as an operating system, although I do feel it's pretty freaking lacking as like a back-end server-grade operating system. Like, it's good for Active Directory, largely because that's just what Active Directory was built on, and nobody's ever really made a convincing replacement for Active Directory on other operating systems. But beyond that, like, if you're running an application server, Windows should usually be your last choice. It's expensive, it's underperformant, it's overcomplicated, and it's a massive target, not only because all of, these big juicy back-end targets are running on it, but also literally like the same exploits that work on, your maiden aunt's Windows PC will typically work against a Windows server you've got access to. So I'm not saying never run Windows as a server OS, but I'm saying that's also part of this monoculture problem. Why don't we have any airlines running on Linux? Why don't we have any of them running on FreeBSD? Why is it that if you've got a problem that takes out all the Windows, it always takes out all the major industry? That's a bad pattern, and we should get away from it. And I would also like to point out that, even if you're saying, well, okay, but I need a little bit of monoculture because I need all my stuff to work. Even if you're saying, we run Linux, that's still not the same level of monoculture, because while you might only run, say, Red Hat Enterprise Linux in your own enterprise, the next one down the road is liable to be running SUSE. The next one down the road from that might be running its own custom Arch. Another one might be fans of, this or that or the other. It's not this complete freaking monoculture. We learned a very long time ago that although there are advantages to monocultures, even in the real world, not just the computer and the software world, they are very dangerous. In agriculture, it used to be extremely popular to have herds of genetically almost completely identical cattle. And that's great because you can have like the perfect cow and you can have 1,000 of the perfect cow. It's great until the perfect disease for your perfect cow hits the herd and the whole freaking herd dies overnight. Whereas if you have a herd of just standard cattle that's a little bit more genetically diverse, you maybe lose 5 to 10% of the herd overnight. It's a huge difference.
Yeah, I would say in this case, even if the airlines were using a Unix operating system on the back end, this mostly took out the endpoints, right? Like CrowdStrike specifically is endpoint protection, where you're going to just take out the machines that run the kiosks and the machines at the desks for the ticket agents. And those, maybe it makes sense for them to be Windows, but it also makes sense to have some way to deal with this. Also, that isn't some guy from IT has to walk around to every machine, boot it in safe mode, run a script to delete a bunch of files, and then reboot it to get the machine to work again.
I'm not sure it makes a lot of sense for those machines to be running Windows either. Like, these kiosk terminals that the agents use. I mean, you ever look over their shoulder? They're not using like standard software. It's pretty much all bespoke apps. And those bespoke applications run on whatever operating system they were designed to run on. So maybe designing them to run on the same OS that's, in your aunt or uncle's machine back home, maybe that wasn't the best idea.
Yeah.
Maybe you should have been building the whole thing to be a little bit more hardened, a little bit more under your control, a little bit less exactly like every crappy machine that every malware author is trying to target regardless.
Could even buy Macs if you're feeling fancy.
I am not.
Ransomware gangs are loving this dumb but deadly ESXi flaw.
So it turns out ESX has this great feature that if you happen to be part of a group called ESX space admins, then you're an admin in ESX. The problem is you don't necessarily have to be an Active Directory administrator in order to create a group called ESXadmins. And so if you have any authority at all in Active Directory, you might be able to just create a group called ESXadmins and add yourself to it. And then when you connect to ESX and log in with your username, ta-da, you're the administrator.
I would point out that even if you are an Active Directory administrator, that doesn't necessarily mean that you should have the keys to the ESXi castle.
Mm-hmm.
Particularly in larger businesses, very frequently there is an Active Directory administrator role that is very specifically like, that's your job, is to deal with Active Directory, and that's pretty much it. And somebody who was hired just to manage Active Directory and, deal with group policy and, adding and manipulating, user records, all that kind of stuff, that is a huge, arcane, Byzantine world that, like I said, can easily occupy an entire role in a larger company. And just because you know how to do that doesn't mean that you should be trusted with monkeying around with the hypervisors within the enterprise.
This exploit is pretty bad just because of how trivial it is. And, this method is also actively being exploited in the wild, which is one of the main reasons we decided to cover it. In this method, if the ESXadmins group doesn't exist, any domain user with the ability to create a group can escalate privileges to full administrative access to any domain-joined ESXi hypervisors by simply creating a group and adding themselves to it, or any other users to that group. Another way of doing it would to just be rename an existing Active Directory group to be ESXadmins. And especially if you can do that to a group you're already in, it might actually leave a lot less of an audit trail than creating a new group. As long as the group is called ESXadmins and you're in it, you're now the administrator.
What's that Anakin and Padme meme? They have patched this, right? Right?
So Broadcom said in a security advisory that it already issued a patch for this vulnerability on June 25th, but only updated Cloud Foundation as recently as July 23rd, which is a month later, which is perhaps why Microsoft reports that this is still being used in the wild.
It's probably also worth pointing out that the CVE was posted on May 29th, which means Broadcom took a month to patch at all, and then took another month after that before they bothered patching the Cloud Foundation. In Malware Jake's words, it seems like they're not serious about security at all, and I don't really see how I could argue with him. That was not well done, Broadcom.
In particular, he says, and then to make it dumber, VMware classified this as a moderate severity vulnerability, despite knowing that ransomware threat actor groups are actively exploiting it.
And looking at the security advisory, ESXi 8 has been patched, but ESXi 7, which is still supported, says no patch planned. That doesn't seem right.
VMware, since the Broadcom acquisition, is firmly in the extract phase of the attract-extract cycle. Broadcom has not been shy about pushing people to upgrade, pushing people into newer versions, not caring about older agreements beyond the level that they are legally required to do so. Prices have shot through the roof for renewals, and they want you on newer versions, and they just don't really seem to care much about legacy anything.
Yeah, some commenters also point out an interesting tidbit that some people might not have considered. That one of the possible problems with joining your ESX to your Active Directory is if you plan to use your ESX to host your domain controller. If the VMs are going to run inside, for your domain controller that are hosting Active Directory are going to run inside VMware, you might not want VMware to depend on Active Directory to let anybody log into it.
Honestly, I would pretty much go so far as to say joining hypervisors to Active Directory is just, it's a really weird move. Like, I get the kind of completionist mindset, like, oh, all the things should belong to the domain, but no, man, the hypervisor really kind of exists at a higher, depending on, which direction you want to look at it from, lower level than the domain does. The hypervisor should be a fully self-sufficient thing with or without the Active Directory domain.
Yeah, I can see arguments the other way of if your MFA system is keystoned into your Active Directory, it makes sense that to log into the hypervisor, you need to go through the two of it. But yeah, if you're going to host your Active Directory in the VM, then definitely don't create the circular dependency. That will not work out well.
But I mean, ultimately, you really need to be hosting your Active Directory under some hypervisor's virtual machines, because bare metal domain controllers are just a path to misery and pain and terror. You really want to have the ability to have regular automated snapshots and fast rollback ability when you're talking about Active Directory, because when Active Directory gets weird and goes south, it is really hard to repair with junkyard surgery. Whereas if you have the ability to just roll it back to a last known good, you can be up and running immediately. Versus over the decades that I've had to support Active Directory, back when they were running on bare metal, I can't tell you how many times I would encounter a half-working Active Directory that just could not be recovered to a fully working condition. So it needs to be virtualized, which means it needs to be under a hypervisor, which means don't make your hypervisor depend on the Active Directory.
Okay, this episode is sponsored by people who support us with PayPal and Patreon. Go to 2.5admins.com/support for details of how you can support us too. Patreon supporters have the option to listen to episodes without ads like this. And it's not just this show. There's Late Night Linux for news, discoveries, audience input, and misanthropy. Linux Matters for upbeat family-friendly adventures. Linux After Dark for silly challenges and philosophical debates. Linux Dev Time about developing with and for Linux. Hybrid Cloud Show for everything public and private cloud. And Ask the Hosts for off-topic questions from you. You can even get some episodes a bit early. We've got a lot going on, and it's only possible because of the people who support us. So if you like what we do and can afford it, it would be great if you could support us too at 2.5admins.com/support. Let's do some free consulting then. But first, just a quick thank you to everyone who supports us with PayPal and Patreon. We really do appreciate that. And if you want to send any questions for Jim and Alan or your feedback, you can email show@2.5admins.com. My friend Nick got into a bit of a pickle, and I thought it would be nice if he could skip the queue with this. So he bought some hard drives for his NAS without realizing that they were SAS drives. And so he wasn't sure what to do. After a bit of research, he decided to buy a PCIe card. And I wanted to know if that was the right move. Should he have just returned them and got SATA ones, or was getting this PCIe card a good move?
Nah, the PCI Express card was absolutely a good move because you get a lot of benefits out of that regardless. Most motherboard SATA and SAS controllers, even on enterprise-grade motherboards, the onboard controller is usually pretty low performance. The vast majority of them that I've seen, even on like Supermicro server boards, they'll top out at roughly 600 to 700 megabytes per second of actual throughput of data. Whereas if you drop in, something like an LSI 9300 host bus adapter in at the same machine with the same drives, assuming the drives are capable of it, obviously. But like with 8 Ironwolf drives, I can usually pull about 1.6 gigabytes per second across an LSI 9300 8i. And you can pick those up on Amazon new for like $70 now.
Oh, wow.
So, I mean, by all means, if you've got SAS drives and you don't have a SAS controller, just buy one. It's worth it.
Yeah. Like Jim said, the thing to look for is HBA, or Host Bus Adapter, which goes back to the SCSI days, but it's basically the card that is your SAS controller. And they do support SATA drives. So if you have the right cables, which is a whole different problem, you can plug SATA drives into the SAS controller as well. So if you feel like, you have an all SSD NAS and you feel like the motherboard SATA controller is what's holding you back, then it might be worth, like Jim said, spending the $75, getting one of these LSI HBAs and plugging the drives into that, and magically start seeing a bunch more performance, especially from SSDs.
Even if you're just running on Rust, you can absolutely see a big performance boost. Like I said, with 8 12 terabyte Ironwolf drives, going from the motherboard controller, which tops out at about 650 megabytes a second, to an LSI 9300, I was seeing upwards of 1.6 gigabytes per second out of the same array, all on Rust, no flash whatsoever, not even a slog or an L2 ARC or whatever. Just the performance of the Rust itself is already more than the motherboard controller could handle on a server-grade motherboard. But drop in that LSI, and like I said, you're up well over a gigabyte a second. I'm actually not quite sure where those do top out. I believe they tend to top out, depending on the workload, at around like 2, maybe 2.1 gigabytes per second. But again, I mean, that's a huge improvement over topping out at 650, which is roughly the maximum performance of a single SATA 3 device. The last thing we'll mention, for those of you who don't have experience with host bus adapters, almost all of them will come with what's called SFF cables rather than individual SATA SAS ports. So you want to look at your card, the LSI 9300 that I've been recommending. It's not the absolute latest and greatest, but like I said, it is an excellent card. That one comes with SFF 8643 ports on it, which means you need to get the correct breakout cable to give you individual SATA SAS cables for your drives if you don't have a backplane, which you probably don't if you need the answer to this question. Now, if you're building a server with all server-grade parts and you're using like a rack mount chassis, then you may have an actual backplane that just takes a direct SFF cable that carries all the data for all the drives connected to the backplane. But typically in the smaller business and consumer space, you're going to be connecting to individual drives, even in cases with hot swap base. So in that case, just make sure you've got the correct breakout cable for your card and drives.
Right, well, we better get out of here then. Remember, show@2.5admins.com if you want to send any questions or your feedback. You can find me at joyrest.com/mastodon.
You can find me at mercenarysysadmin.com.
And if you really have to, I'm at Alan Jude.
We'll see you next week.